Good evening, everyone. Welcome to today's webinar. Today, I am Dipan Roy on behalf of Developers Club KGEC is here to present our next webinar on bridging the gap between IoT and web by making an interactive dashboard. So today we'll have Ritankar from our own college with us. He will be using the same template that Ayushman used few days back to make a basic dashboard. Using the same dashboard, Ritankar will be providing the backend using an Node MCU board, where you can see that as far as the board is utilizing the system, the dashboard will automatically change the lights or whatever device is connected to as required on your command.
Am I audible?
Hello. So I guess all of you can hear me. If any one of you are live, please let me know that I am audible or not. I'll be handing over the session to Ritankar in a few moments. And from that moment, Ritankar will be showing you with the basics. So let's start with Ritankar on today's session on bridging the gap between IoT and web. Yes, you are audible. Ritankar, you can go ahead now.
Okay, so if I'm audible right now,
Yeah, Ritankar, you are completely audible.
okay. So what we've got here is how do you connect the web with IoT? So last day Ayushman built a website or some kind of dashboard that you can see already in the previous video. where I use some front-end technologies for making a website that is cool enough. So what today I'm going to be doing is doing the backend stuff for the website so that we can control few appliances with the website. All right. So as you can see, this is bridging the web with IoT. So what is IoT actually? Always Google knows better. The Internet of Things is a system of integrated computing devices, mechanical and digital devices, uh, that have unique identities and ability to transfer data over a network without recurring human to human or human to computer interactions. Okay, that's a copy dictionary. That's a copy information from Wikipedia. All right. So basically, what we're gonna do today is we're gonna see how the website that Ayushman made with HTML, CSS, JavaScript can be actually transformed into something actual of use. That is a controller or a thing that you can control basically any devices or you can read data from anything. Okay. So what are the actual components that you're gonna need? So the components that we're gonna need today is a Node MCU. Obviously, you can see it over here. So it's Node MCU over here. And the next thing what you're gonna need is LM35 temperature sensor. I'm gonna bring it out in a moment soon, so you can see that later. We're gonna also need a servo motor so that we can control and basically use the server that slider that Ayushman made. You're gonna need a LED and a lamp and a BC547 NPN transistor. And obviously we're gonna need Ayushman's dashboard for that because nothing is possible without a cute front end. Fine. So the circuit diagram goes as this. Yeah, you can see it better right now. So here is our node MCU, and here's the servo motor. This is a BC547 transistor. This is L21K, and this is the LED along with the LM335. Okay, so now without investing any more time, I'm just gonna jump into the breadboard and start making the circuit right away. So here's the servo. Just hold on with me for a second. I'm gonna bring on all my devices and actually have to search for it. Why did I keep it? So you can see this LM335 actually. I don't know if it's focusing or not. So okay, you can't see that. But here's the LM335. That is gonna be our temperature sensor. We're gonna keep it over here. And making this happen. Okay, so here's our power source as well. We got it right here. You're also going to need a BC547 or any kind of NPN transistor that has a sufficient gain. So it looks confusing because both looks almost similar because it comes in the same identical package. So I'll keep the transistor over there. What else did we need? We also need a, okay, let's get an LED right now. We also have an LED here. Then what else do we need? We need a lamp. Okay, there is a lamp. You can probably guess that I salvaged it from an old car, like toy car. I mean, you should always know that. And the last thing that we're gonna need is a USB cable. Obviously, how else I'm gonna upload the code? So here is the USB cable. I don't need to show it right now. Fine. So I'll go to the circuitry and plug that in and start doing it probably so that I can finish it up. Okay, things are right now very messy. So obviously I'm gonna need few jumper cables as well. So I've got all the jumper cables right now, right here. A lot of it. Okay. So I'll just start making a circuit as this right here. Fine. Just bear with me because it will take a few seconds. This is the transistor. We are basically using this transistor so that we can drive this small lamp over here. This lamp approximately gives a resistance of 1 kilo ohms and cannot be driven directly from this board since current issues because this board cannot actually provide sufficient current to run this lamp and can burn itself. So you're gonna need this transistor for that. Obviously, we're gonna need two resistors for that as well because we need to drive this transistor for that. And this is probably our temperature sensor. I'm gonna quickly fix it up and I can get going, but just bear with me. Okay. So temperature sensor goes as this LM35. So how would someone know that this LM35 what it is actually and what does it require for connecting and all these things? So for that we're gonna go to this data sheet of LM35. We're gonna refer to that. We're gonna go for the data sheet. Always go for data sheet. So it's made by Texas Instruments and I already have the data sheet for me. And I'm gonna do in the data sheet. It will take a few moments and here it is. So as you can see, this is the LM35 and the version we have got is DX. It's not DT. So we are using this TP-TO92 package and the pin 3 of that is ground. So we're going to connect this to the ground. And for that, so I'm fixing up this rail for the ground connections. So this is the ground rail. All right. So I'm going to take a jumper wire very lightly and I'm going to quickly fix it up. As you can see, I'm connecting the ground rails. It takes sometimes. Well, if you have any questions, you can just ask me over there, and Ayushman over the call can convey the questions to me. So the ground connection is set up as required, and then what we're gonna do is connect the VS. VS stands for the voltage source. So we're gonna connect the VS that is the pin 1 to the voltage source. All right. And since we are using that rail for the ground connection, we can use the upper rail for the VS or the voltage source, just like that. And you should know one thing that this breadboard is connected up to fifth row. I mean fifth column. This connection is a unified connection. The upper one is also a unified connection, which is obviously electrically separated. And this whole region, this whole column is a different connection. So for that reason, we are not going to use this connection for a while, and we're going to keep ourselves to this connection. So we have connected the temperature sensor pretty well. Okay, so this is almost fine. So for the data out, as you can see, so okay, so I've connected this one. Okay, for the data out or V out, that is the temperature analog value that we're gonna get, we're gonna connect the middle portion of this middle one to something like this analog value. So as you can see, this node MCU has an analog pin which accepts the analog value that is read by this temperature sensor. All right. So we're gonna connect this V out. Okay, I forgot to switch. All right. So we're gonna connect this V out to the analog sensor over here. Yeah, you can probably see that, or probably you cannot see this. It's very hard to see, but this is the analog out. As you can depict it in the diagram, this is the analog out. All right. So I'm gonna connect this to this one. And do feel free to ask any questions again. Ayushman can convey that to me. Okay. So basically, we are done with this connection. So this one is shipped. The next what we're gonna do is connect the D0 pin to this LED over here. So this D0 pin lies on the top left of this board. And first of all, we're gonna check this LED if it's working. What I'm about to do is very stupid and you shouldn't do it. Let me use a register. So I'm just gonna check this LED if it's working or not. Very simple things you can do. Yeah, it's fair. It's working. Fine. So we're gonna connect this LED right now. So I again forgot you to show the LED check. So okay, I just checked the LED and it's working. That's the conclusion. So I'm gonna connect this LED as depicted in this diagram. So this LED is connected to D0 to a resistor and it goes to ground. I'm gonna connect it like that. Okay. So we can use a 10K resistor for that. 10K, not 10K actually. It's 10 ohm, 100 ohm probably. Doesn't matter actually. It really doesn't matter. So I've connected this and I'm gonna use another jumper cable for this to connect it to the ground. I know, hardware is pretty boring. And it's very hard to do as well because the jumpers don't stick out very good. But probably it's quite set and it's great. So we have done with the LED as well. Next, what we gotta do is the lamp one. Fine. So let's get to the lamp. So this is the transistor we're using. That's classic BC447. That is very available to everyone, and it costs only 50 paisa. You say half a rupee. Doesn't matter. So we can use this. Again, you should refer to the datasheet. So this is the transistor we're gonna use today. So this is a BC547, as I said. You also can refer to the datasheet if you're going to use it. But since I know I'm not going to use it right now, so let me tell you a bit. So the first pin from the left is the collector. The second one is the base, and the third one is the emitter. So as a classic NPN connection, we're going to do over here. We're going to fix it over some right here, and we're going to fix up this lamp, which draws a lot of current. And fixing up a lamp is really painful, trust me, because it doesn't slide well. This cables are very thin and doesn't go well. Okay, so the lamp is currently inside of that. Now what we're gonna do is, it's awkward. Stay down, little boy. Stay down. Yeah. So this connections have to be made with the with the with the second pin of the node MCU, that is the D2. So we're gonna connect this D2 wire resistor to the base of the transistor of BC47, 547 I mean. Okay. So we're gonna connect this D2, really a mess. We're connecting this D2 and we're gonna extend this connection via jumper wire, and we're connecting to the base of the transistor from behind of the transistor, obviously. And lastly, the connection is left is the emitter. So as we all know, this emitter will go to the ground connection of the board. So we're gonna go ahead and put it in from the emitter into the ground. And I hope probably I'm doing all this right, because if I don't, I'll blow up something, and that won't be good for me, as it's gonna cost me money. I don't have good hopes with this temperature sensor. I don't know why. So this is all fixed, and the last thing what we are left with is one fat ass. I mean, fat server. Pardon me. Okay. So probably this is gonna be everything for now, because we're gonna connect the server later. So let me taste it with this. So going back to that, we're gonna go to what we're gonna code right now. Let me expand the window a little bit. We're gonna erase the code as we do every time, and let's save this file named, I don't know, like what, web plus IoT. Sounds good. So for this, we're gonna use this Wi-Fi functionality of this ESP8266. For that, we're gonna include this library first. That goes with include, that is ESP8266 Wi-Fi.h. As you can see, it turns orange. That means this library actually exists. Okay. So we're also gonna need this to connect to our Wi-Fi. Sorry. It basically connects to the multiple Wi-Fi or access points that you have in your room, and we're gonna include another one, that is ESP. It should turn to gray or orange. Okay, we missed the P over there, so we're gonna import this library as well. So for now we are done, or we can just include this servo library that we might use if we get some more time and if people are actually interested for this. And so let's define our pins now. So we're going to define this pin D0 as our lamp 1. So as is depicted in this diagram, uh, okay. So you can see this D0 and D2 are the two pins that connect into the lamp and the LED. So we're going to define these pins. We could have also used constant to define this, but we'll just go with the old-fashioned C way. Okay, so we are done with the definitions of the pins, and we're gonna define a class. We're not gonna define a class. We're gonna instantiate an object of this class, that is Wi-Fi multi. That is Wi-Fi multi, and we're gonna import. We're gonna use this web server as well. Copy pasting is the best way. So we're going to define a server that we're going to use for this project, and we're going to define the port as 80 because that's the standard port. And let's write our setup function because we always need to write a setup function. So for the setup function, we're going to do as everyone does. You should basically know that there are two functions that are essentially required for that. One is setup and one other one is loop. The setup runs for only one time as the device is booted, and the loop keeps on running. All right. So in the setup functions, we're gonna define the pin modes. So since we're using these pins, we're gonna define pin L1. We're gonna define L1 pin that is D0 as output because we're gonna light up the lights, obviously. And same goes with L2. And another one is we're gonna define this pin mode A0 as input. And why did we do that? For that, we have the answer in the diagram. As we can see in the diagram is, you can see this temperature sensor that is connected to A0. All right, that is the analog. Fine. So we're going to define this analog pin as A0, and that will be the input for now. And that is basically all for our pin definition. Now let's turn off the serial monitor. Serial monitor is basically the monitor, or you can say it's a serial communication between your computer or with your ESP8266 device. Now we're gonna define few Wi-Fi or access points. Wi-Fi multi we use to instantiate this object of class this. So we're gonna use this now. We're gonna use Wi-Fi multi dot add access point. It was in caps, and we're gonna give away my Wi-Fi or router credentials. So my router credentials goes like this. This is my SSID and this is my password. So we can add another access point if you want. You can turn on your phone's Wi-Fi or phone's hotspot and use this as an access point as well. But we're not going to do it because I know my Wi-Fi works and I'm going to use it that. And we're going to define this ESP's Wi-Fi mode as a station, or I should say as a client, as a Wi-Fi client. For that, we're going to use this predefined STA. So this line basically means that we're going to use this ESP's Wi-Fi as a client, as a Wi-Fi client. Cool. So we're gonna keep on trying to connect to my Wi-Fi until and unless it is not connected. So WL connected is basically a what it is said. I don't seem to recall it. It is actually an enumeration so that you can get this WL connected signifies a numeric digit into this Wi-Fi library, which signifies that it is basically connected. So if it is connected, while it is not connected, we're gonna delay our code by 500 milliseconds, and we're gonna see your print waiting to get connected. Cool. Yeah. So we are waiting to get connected, and it finally connects. Then what we're gonna do is we're gonna print out this. Uh, what it said. We're gonna print out. We're gonna print out that our Wi-Fi is connected successfully, or I should say just connected, and we're gonna print out the local IP of the Wi-Fi of our ESP. I mean, on local IP. All right. We're gonna call the function that will return the local IP, and we're gonna print it to a serial monitor. And what we're gonna do now is define the routes, which routes we are actually gonna use for this. So as you can see that we have a server named server and that is connecting to the port 80. So what we're gonna do is handle the routes. So first, now we're gonna do is routes for our device, I should say. So we're gonna define few routes. Server dot on basically is the method of the class web server that accepts two arguments, and both are positional arguments. First one is the route that we're gonna route into. So that forward slash basically means is the home directory or the home route for our server. And for that we're gonna define a function. Let's say handle route, handle route. All right. So what is handle route? We haven't defined this handle route yet. So we need to define it somewhere, right? So for that we're gonna define a function named handle route. So let's define all these functions over here. Handlers. These are all handlers. So what was our function? We're gonna use a void type return and we're gonna handle the root. Okay. So what handle root will do is basically send a response to the server. This is the send response, which again accepts three arguments. First one is a status code, that is a HTTP OK that symbolizes 200. We can also define how the data is. What is the type of data? That is basically a text slash HTML data. And we're going to define what to print. So here is a place where we actually need to send our HTTP response, that is HTML and slash HTML. And here we need to send all this data information that we're going to send. Okay. So for that, what we're going to do is resort to Ayushman. Okay. So basically, we're going to open this GitHub repo and see where did Ayushman post. So let it open. We basically need to do is we're going to take the entire web page that Ayushman has made and wait a minute. Where did Ayushman keep it? We're going to go to this KGEC. We're going to go to my dashboard and switch to KGEC where we can find Ayushman's code. So it's loading right now. we're gonna go to the repos. Here's the repos. So this was the developing applications for web. This was a repo made by Aishma. So that's how we're gonna use it. Okay. So we're gonna open this index.html page, and you can find this lot of code over here that probably doesn't make sense for us. Let's say, hope he doesn't get offended. So what we're basically gonna do is take this entire text as string, and we can basically take this entire text as string, and we're gonna paste it somewhere. Let's say string web page, and we're gonna do this. Obviously, we're not gonna do this because it will kill our RAM, and our measly RAM of 4 KB will get dead very soon. So what we're gonna do is take a new tab and name it name it what? Let's say name it page.h. We're gonna make a header file of C. You know that what is a header file, and we're gonna define a string over here. So we're gonna use constant character array, and let's say name it landing page. That is gonna be our page, and we're gonna define this into the progmem. Now, what progmem basically is the program memory of the ESP8266. So we're going to define the progmem like this. Now, don't ask me why it's defined like this because that's what the datasheet says. So it was probably 5, and what we're going to put it into this section. We can put the entire HTML content here. This is basically a string, and probably I didn't copy the whole string. So let me copy this entire website top to bottom, and we're gonna paste it in this section. Cool, cool, isn't it? Now, since this is a very straightforwardly, it's a string. It's just a string. So we're gonna remove this link to the style sheet, and we're gonna add the style tag inline. And what we're gonna do is we're gonna take the entire CSS file from Ayushman's file, repo, and simply copy and paste. Let we developers love to do it. Who writes 200 lines of CSS codes? Come on. And we just paste it like this. It may look naive, but that's how we do it. Did I get it right? Probably I did. So here's the style ends. So we did the style tag. All right. We're gonna remove. We're gonna do the same with the JavaScript file that he wrote. Correct. And we're gonna take the JavaScript file. So in this thing, Ayushman used open URL, open weather URL, open weather URL, and the API key for fetching the weather. But since we are using this temperature sensor over here, we're not gonna take these 2 lines to copy. Okay, what did I do? No. So we're gonna copy this down to the end. We copied the entire file and we're gonna paste it into the script tag. Let's make it a bit prettier by slightly removing or just shifting it this way. It looks a bit pretty, but it's actually not pretty. Basically, what we did is copy the entire website that Ayushman made and put it in a header file called page.h inside the constant character array that named as landing page inside the problem of the ESP8266. All right. So this is it. So basically, this load data function will fail in our JavaScript because we don't have this open URL, and everything should work correctly. Now, what we're gonna do is we're gonna include this page. We're gonna hash include page.h. So we needed to include this page as well because this contains a string of data, and we included this as this. All right. So for now, and we're gonna pass this landing page variable, what we have here, this landing page variable. We're gonna pass this landing page variable into this. As we already know that this function send is a method of the server class, that is this object of this class takes three arguments. One is the response code, that is HTTP OK, and is the text type, and another one is the landing page. All right. So we got the landing page over here. That is basically our HTML file. And now we're gonna do a test run. At last, let's see how it goes. So for that, we're gonna go to this and we're gonna take my USB cable. Ayushman, if you're hearing, can you let me know if I'm audible correctly or not? I don't know. I'm not getting any feedback or something. Can you please let me know? All right. So this is it. We are connected. And what we're gonna do is now upload this code. I'm gonna move slightly towards this side, and we're gonna check whether everything is actually all right or not. So you can see this COM port is 6, and probably that is my port, and we're gonna check if the board is right or not. So everything seems to be fine, and we're on COM port, and we're gonna hit upload. First of all, we need to compile, obviously. Let's see if the compilation is correctly done or not. So for the best, it takes a quite long time to compile these things because it's ESP, and we are basically hybrid thing out it with Arduino. Exactly do. I hope it runs, and it should fail because every time it should fail because first compilation never runs. And still compiling. God, it's already 44 minutes. We didn't show it. Come on, compile already. It takes a lot of time. Come on, what's wrong with you? Yeah. Oh my God, we are really lucky. Compile at the first go. It shows this nice little uploading sign, and we are uploaded. We effectively open up the serial monitor, and you see it's connected to 192.168.2. So we're gonna copy this one, and what we're gonna do is, sorry, not gonna do that. We can paste it in this cat. It refused. Why did it refuse? Something is really wrong. We are getting connected, but it is not working, and I don't know why it's not working. We are handling the route as needed, and we are also printing the local IP. Oh, you know what? We are not actually handling the client. See, this happens every time. We're gonna do this. We forgot to do this. We're gonna handle the client. Whenever a client like my PC is requesting to the server over the ESP8266, we need to handle it as well. Now it should probably run, and we're gonna compile this thing over again, and let's hope for the best now. It should compile a bit faster right now. Now, the thing is why this handle client function is over this while loop function. This handle client function or method of the server class needs to be inside the loop function because we don't know when the client is gonna request. So we're gonna keep repeating and like running your npm server or npm server or node-bound. If you're getting any reference, it's fine. Just basically we need to check every time whether there is an incoming request to our server. Else everyone gonna see this site cannot be reached. So it's done uploading. We're gonna refresh this page, and still we don't see anything. That's sad. Let's reset, connected, and we don't see anything. That is really pathetic. So why did we go wrong? We're gonna check if we are getting into this point or not. We're gonna again hit upload. I hope something is fishy. It's not working. We are handling the client as well. You see, we again forgot this one. We need to start the server first before we handle the client. It happens every time. Let's say a debug message over here. Now hopefully it runs right now. And probably that's was the thing that we were missing. We missed two functions like this. Should always have a handy documentation with you. You can always get a handy documentation. Okay, we forget this one, but it's called code. So for this documentation, you can go to expressive expressive espresso expressive.com, and you can get a good overview of this ESP8266 and all of the functions that are currently into this. Now you can get anything or any documentation that we need from here. Get documents over here, and basically you can get all the documentation from here. So it's done. So now that it's uploading, we hope that it runs right now. Probably the IP is still the same, and we're gonna hit run and see it's running. Voila! But you know what? It doesn't do anything. Even if you click, it's the same old H1 space that does literally nothing. And the fetch API is not even working. You can see a lots of errors over here in the console. See, it's a lot of error because the load data function didn't work. So now what we're gonna do is to make this thing responsive and interactive. That was our main goal. So you can see our so it doesn't do anything right now. All right. So we're gonna make it responsive or make it do things that we want it to do. Now what we're gonna do is we're basically gonna create two more routes. Let's do it with the same way. So we're gonna handle this route as slash on, and we're gonna create another callback function. We're gonna say light on. All right. And another function will be lights off. We're gonna do the same for the light off, and it's off. Okay. And we're gonna get a handler function for this as well. So now typically you shouldn't do this. You should always use camel casing and all these things, but let's leave it up to the geeks for now. And let's go to the light off. Light on function. So whenever this function is called, we're gonna do is we're not gonna do a secret of printer because it's working. Now this function is when it's called, we're gonna do this digital write. I hope you are all familiar with this function. We're gonna do digital write L1 L1. Let's okay. We'll write L1 and we're gonna set it to high since we are turning it on. And we're gonna do light on off, and we're gonna do digital write L2. It's gonna be high. No, sorry, it's gonna be low. World does turnover, everyone is high. Okay. So those two handler routes are okay. And whenever we click this, it should turn this light on and off. And and that's it basically. No, that's not it actually. We're gonna go to this JavaScript function. I hope you all know what's going on here because Ayushman already took a session. And if you don't know, just find some time to get into this video and check. And what he's doing is basically calling three functions, that is load weather data, render lights, and render sliders. So we're gonna go to the render lights, rendering a lot of things apparently. We go to the render lights functions. Where is the render lights? So here it is. So what it is doing is basically we are okay. Why I'm explaining this? We're gonna take this element. Element has this device name and device ID. Everything's good and fine. And what we're gonna do is inside this callback function, which ends here, what he has done. Okay, so We are actually going to check for clicks. And how are we going to do that? Oh, we are changing the status, I guess. He was changing the status of the light from there. Okay. So whenever a light is clicked, what he does is he calls this render lights over here. Render lights basically changes the inner HTML, and we're gonna change things over here. So element.status, he's switching the lights over here. So what we're gonna do is call the fetch function that he did in this load data, load JSON data. But did he do it? Did he do it at all? Okay, so load by the data. What he did is awaited for this fetch with this URL. Since we are in the root URL, we're gonna do is call this function. We're gonna call our this routes, which will eventually call this light on function. So whenever in the web server we do this, whenever we do this slash on and the light is getting on, we're gonna call this slash on function from there, from this route. So where were we? We were in this section. Okay, so here is a place where we're gonna change things. So we're gonna check if element dot status is true, then we're gonna fetch on. We're gonna turn it on if the fetch is true. So we're gonna turn it on. All right, and else we're gonna turn it off. Simple, isn't it? But what we're gonna do is, since we have two buttons or two, yeah, it's called buttons only. So since we've got two buttons with two different device ID, we're gonna check which device ID is being fetched. So as we can see, this light has two devices. This device one and device two, which is a JSON file. This is an array of lights that calls divide ID and device ID one or two. So we're gonna pass the ID along with the call method. I hope you all are aware of these query parameters. I can't find it. Where did it go? God, this is confusing. Okay, here it is. So I hope you are aware with this query parameters. So basically, we can do an interrogation sign, and we're gonna assign this ID would be equal to element dot device ID. So basically, what we're gonna do is pass this ID of the lights that we are currently clicking, so that our ESP also knows that which light he it has to turn on or off. All right, we are passing the IDs as well. Let's clean the code a little bit, and basically that's it. Now the thing is, you can see this right routes doesn't match quite well. It's on and it's off, and we are only listening to on and off. But since we're using this query parameters, we can also listen. We can also check whether the ID is one or two or anything like that. We can also check that. All right. So for that, what you're gonna do is we have this server. Again, the server is in our rescue. We're gonna do is we define our integer ID to be server dot arg, that stands for parameter arguments arg. We were passing this ID, that will take this ID, and this ID comes from this one, this ID. We're gonna checking. We're gonna go to check if what this ID is. We're gonna convert it into integer so that it is. So if this ID is equal one, what we're gonna do is turn this L1 hide, else if what is this L1 else if the ID is equal to 2, what we will do is we'll turn the light 2 to be high. And we can do the pretty similar thing over here. We're just gonna copy this thing up. We're gonna check again the same thing. We're gonna turn it low. Good to go. Do you understand what we did here? So the summary what we did here is we're gonna check this route. If this route is being called with this light on function will be executed, and this route is being visited once the user clicks on a button, and that will trigger this fetch function that will eventually put up a GET request into a server, HTTP server, with this route. We are not using this HTTP slash colon colon localhost or something or 192 because we know that we are in a root server. Fine. I guess that will make the lights go right. Let's upload it and cross our fingers. I hope it runs well. Currently compiling. I hope you are able to see this little window. I really hope so. The sketch is compiling. Come on, compile already. Yeah, it's compiled and it's loading right now. You can see this blue LED is flashing like anything. So it's 71% completed. Now it is the moment of truth. So what we're gonna do is we're gonna separate this window. So now what we're gonna do is keep a sharp eye on this device. Yeah, this device. Keep a sharp eye on this one. And look over here. As soon as we turn off, it does anything. Does it? It doesn't do anything. Wow, interesting. That's sad as well. So let's see what's wrong in the console. Server responded with a 404 that is not found. Okay, that didn't sound good. So as I told you, this route will slash on, and if I say this ID is equal to 1, now something should happen. As soon as I hit enter, this LED goes off, and as soon as I hit 2 with this, okay, let's see if we can turn it off. Okay, so seems like when we are clicking on off, this one should work, and on, and this blue light will go off right now. It goes off. So this route is working. But the thing is, it's not working pretty well on the server, on the dashboard. So we're going to remove this alert first. So let's get into this quickly. We're going to change this alert and remove this. And what was going wrong? We are passing the status as well, along with the off function, and we are passing the ID as well. But something seems to be wrong in our server because it's not responding correctly. So this is the thing. So that's it. That's it. Let's remove this else if for now because there is only one and two options are actually available. So just send a response as well. We're gonna send a response like 200 with like text slash HTML, and we're gonna say done, and we're gonna copy this line of code and we're gonna paste it over here as well so that we know that this thing is actually working, and we're gonna hit load. The sketch is being compiled right now. I hope that I think it's working, but I'm sure. You know what? I'm really stupid. Everything was working, but I forgot to plug this battery in. Seriously, it shouldn't be posting anymore. Come on, who forgets to put the battery inside? So we are putting this battery inside, and the negative goes to the negative. And always remember, we're gonna get a common ground connections as well. So since this ESP8266 is powered is by this USB cable, we're gonna connect the ground of a cable with the ground of a lithium polymer battery. We need to have a common ground. You should see this is a ground connection. You can see that up there. Fine. So this is it. Let's see if it is actually working. So we're gonna hit refresh. Let's see that it's working. So we basically turned on this light. Let's turn it off. It turned off, and that blue light turned on. This is the board light that is invertly connected to the this pin of this light. So let's turn it on again. How do you feel? As we click this light, this turns on. Let's test the other machine. Who writes machine? It's another lamp. Come on. Lamp, buddy, turn on. Hey lamp. You alright, lamp? Mr. Lamp. Mr. Lamp doesn't seem to respond pretty well. So before we criticize on the software part, we're gonna check the hardware as well. So for that, we're gonna take our multimeter, and for that, we need to find our multimeter. That's pathetic. So let's dry run through this shortly. We are checking if this transistor is actually working or not. So what we're gonna do is take this 3.3 volts off of this pin, and we're gonna short this so this turns on. But the thing is, the lamp doesn't seem to work. Hey lamp, come on lamp. The lamp is not working. Okay, this lamp is working now. Okay, the lamp is working. Okay, so I'm gonna turn off the lamp. So there was some loose connections with the lamp, and as we can see, it's working correctly right now. And we're gonna turn on the lamp. On. We turn off the lamp. It's off. We're gonna turn on the lamp. Again, it's on. It's off. It's on. Okay, you get the point. We're gonna turn on this light as well. So both of the lights are on right now. We're gonna turn off the lamp and we're gonna turn off the light. Voila, it's working. So this dashboard is working. Oh, I can do this all day. Come on. So let's keep both of this on because everyone likes lights. And we're gonna say goodbye to our darkness, who happens to be our old friend. Okay. So this dashboard kind of works right now, isn't it? So since this is working, we're gonna do this on the temperature part as well because we're gonna see if the temperature is being transmitted properly. So the weather near me is 22 degrees C, but it is not actually 22 degrees C. So let's define another route. So this time it's gonna be actually route with server.on, and let's name this route as /temp, stands for temperature, and let's handle this route as temp, get temp, maybe I don't know, get temperature. So let's define another function which is called দাঁড়া কি হচ্ছে নাকি? Where did I go? কোথায় ছিলাম? কোথায়? হ্যাঁ করলাম। আচ্ছা লাইট কি জ্বলেছে দেখেছিস তো? লাইট জ্বলেছে দেখেছিস তো? আচ্ছা লাইট জ্বলেছে দেখছিস তো? All right, I get it. So that's great. Probably you can guess there was some technical issue over here, and I don't know where did I go. Okay. So did you see this light pod? Because I don't know if you're seeing this or not. I'm just mumbling like a lonely person. Let's not get out of the context. And so I guess we were here and going analog read. We're gonna read the value from the temperature sensor. So I'm gonna repeat myself. So in the datasheet, you can find this. This output will be stepping 10 millivolts with per degree C. So for 0 degree C, we'll get a output of 0 volts. All right. So for 1 degree C, we'll get an output of 10 millivolts. So as we know, this ESP86 is a 10-bit resolution device. 10-bit resolution stands for 0 to 1023 of data points. So this our sensor will basically read 10 to 1023 data, and we're gonna basically convert it into useful data. So for that, what we're gonna do is we're gonna read this temperature value, and we're gonna set the temperature value to be temperature into multiplied by sorry, actually it will be multiplied by 3300 volts. So you know this ESP266 is powered by 3.3 volts of voltage, obviously, and we're gonna basically multiply these values. So a value or temperature read value of 0 will fetch us 0 volts, and a temperature read value of 1023 will fetch us 3.3 volts because that's the resolution we have. So for that, we are good to go, and we're gonna divide it with our resolution value. That's good to go. But since that is 10 millivolts, we're gonna divide it with 110 because you know the stepping is 10 millivolts, but we are multiplying with 3300 millivolts. Since it is 10 volt, we'll divide it with 10 and we'll represent it 330. Good to go. I think you got the logic over here. And that is our basic temperature value. So we're gonna send it by a server. We're gonna send it 200, and that will be of type text slash HTML. That will be of string. Forget the comma. That will be of type string. We're gonna cast it to string type, and we're gonna put the value because our client loves string. So that is our get temperature. So now what Ayushman did is basically load data, weather data, where we fetched the response via this open weather URL. But since we're using our own server, we're not gonna use this URL, and we're gonna basically modify this function. So let's say the let response, we're gonna fetch our temperature. Fine, we're done. And the data, what would be is So sorry for that. Anyway, so that would be data, and where were we? We were in this position. So the response would be awaiting this fetch. What am I rumbling about? Okay. So the server is gonna fetch us our temperature in string from this get temp handler, and we give this value string, and this will be the temperature. But what we are getting is a text value, not a JSON value as we used. So we're gonna remove this condition and this temperature, and what we basically are gonna do is we're gonna remove this inner text of the domain conditions because we don't have the conditions yet. Write storm like this. Oh my God. And we're gonna await the response text. We're gonna write it into the HTML. Await response dot text. So whatever response we are getting from this fetch, we're gonna get rid of the headers, the query params, or whatever we are getting from the response, and we're gonna get the text only. So that will be basically our temperature data. So let's hit upload and see whether it's working or not. So as you can see, your alert is still on like this. Meanwhile, we can also connect this servo. But honestly, I hate using servos because they are really messy. Takes a lot of juice from your battery. Okay, so value was not declared. Oh, that is a temperature value. Okay, so it's 10. Value. All right. So I'm gonna fix up a random var over here because this is nonsense and probably won't be visible very usefully. I'm getting rid of my jumper var like this. Loopy. Okay, get that. We're gonna use three more jumper vars. We're gonna connect it to the ground. So this brown one goes to the ground. Where do I put it? Okay, let me do it later. So it's loaded. We're gonna check the responses. Okay, so when weather URL is not defined. My throat is killing me, by the way. So are we using anything like that? We're not. Oh, I think I need to restart the server. Right, it's 40. Wait a minute, it's not 43 my room. I know I'm inside the room, but still it shouldn't be 43. It's too hot of me. We can hit refresh. You know what? We don't want to keep refreshing, so we're gonna hit a timer. We're gonna set up a set interval timer, which will trigger every 3 seconds, and use this callback load with the data with 3 seconds. My voice is really weird, I know, because I've got cold. But so we're gonna compile now, and let's see if it's working or not. What we basically did is we included a timer of 3 seconds so that in each 3 seconds, this load data function will be triggered and we'll see the temperature updates in real time. And let it compile. So that's it. So let's go to the dashboard and hit refresh. So the dashboard is loaded. Now it shows the actual temperature. It's 27. Let's turn on the lights. The light as well. 42. I think something is wrong with this temperature sensor. All right. So basically, that's it. I really don't want to go on with the servo because my throat is kind of ruined. All right. I think I'm gonna pause. You have to follow up right on the YouTube chat, maybe. No, it's fine. If there is any questions, I'm ready to answer there. I guess only six are watching, and probably there won't be any questions as always. So I think that's it. Obviously, you can use Arduino, but the thing is, with Arduino, we don't get the Wi-Fi capabilities. So for that, you're gonna need a USB, which has inbuilt Wi-Fi and is way cheaper than Arduino. So there is no questions, I guess. No, that's all because we're already having hard time speaking. You can probably get it in my voice. Yeah. Do subscribe. Who said that? Who said that?